they will get quite a bit easier once you do a few more, because you are doing the same thing over and over. Honestly, the majority of the struggle probably should still be doing in the derivative. So you remember back in Unit 2, I said the more comfortable you are with product rule and quotient rule and chain rule, how it would make the rest of the semester seem easier. This is what I was kind of talking about. Okay, so for the first derivative, the derivative of e to something is going to be e to something, but because of chain rule, you also needed a negative 2x. So if you forgot chain rule, all the time you spent on this question, it just wasn't going to work out for you. If you're going to be using these derivatives, you should really double and triple check that you feel correct about it before you keep going. And then for the second derivative, I'm going to pull the negative 2 out front. But for the second derivative, you need to do product rule. We've got x times e to the negative x squared. So derivative of x would be 1 times e to the negative x squared left alone, plus x left alone, times the derivative of e to the negative x squared, which I've already done before. In fact, it's right here. I mean, I could just steal my work there, but so that needs a e to the negative x squared times chain rule, so times a negative 2x times a negative 2x, and there was already one x there, so that makes that an x squared. Okay, so I don't like having to deal with the second derivative if I don't have to, but if I need concavity, the function and the first derivative tell me nothing about concavity. Your graph can be increased, by the way, just so that you guys know. Increasing, decreasing, and stuff has nothing to do with concavity. You can have a graph that's increasing that's concave up, but you can also have a graph that is increasing that's concave down. Likewise, you could have a function that's decreasing that's concave up, but you could also have a function that's decreasing that's concave down. So increasing and decreasing don't tell you anything about concavity. You need second derivative. Okay, so that we're not testing our life away, just randomly guessing x values. The only places where concavity might be changing is when the second derivative is 0 or undefined. So I am going to try to pull out another GCF here. These both have an e to the negative x squared. So that looks like that. So I can set this factor equal to 0 and solve. And that never happens. The next closest you could do is take the log of both sides, but you can't take the log of 0. So this side never happens. But over here, this does happen. And in fact, for some of you, if you got half of the correct answer, the mistake that you did is right here. It's about to occur to you right now. You get x squared is a half. So how do you undo a square? Square root plus or minus. So we have, everybody has taken that part of the test. Again, I've got a few more people that still need to finish the Unit 3 test, but in the Unit 3 test, there was an FRQ where you were trying to find a point, and at the very end, you guys would be surprised. A lot of you did it correctly, but at the end, you took the square root of both sides and you didn't do plus or minus, so you had half of the answer, so you were missing a point there. So when you square root both sides, you have to put plus or minus or you lost one of the things. And it would mess you up here too, because you would only get one of those. Okay, so is that all I needed to do to know that answer? Unfortunately, no. This is just to find the places it might change direction. These are the potential inflection points. You still have to actually test around it. So here's the square root of a half. Here's negative square root of a half. I could test 0 in the second derivative. Negative, positive, positive would be negative. When the second derivative is negative, it's concave down. Pick something bigger than the square root of a half. It can be anything. So if you're not sure how big the square root of a half is, pick something like 10. Pick something that's obviously bigger. And then plug that into the second derivative, if that's what you want. Negative, positive, negative is positive, so concave up. And then test over here, like maybe negative 10 into the second derivative. Negative, positive, negative was positive, so concave up. And I'm kind of scrunching my work here, but this is where they came up with that as an answer. At positive square root of 1/2, the concavity was changing, but also at negative square root of 1/2, the concavity is changing. So they're asking for points of inflection. That's making you go through the whole process. That's the very last thing that you could discover in this.